in pHooey, we're going to talk about pH calculations. I did not come up with this name. Okay. Our objectives are we are going to become familiar with logarithmic scales. We should understand that pH is a logarithmic scale and what that means. We're going to calculate pH, pOH, and concentration of hydroxide ions and concentration of hydrogen ions, given any one of those variables. And we're going to use concentration notation. One of you guys mentioned before, eyes up here, Gabby, that the brackets here means concentration of hydroxide ion and concentration of hydrogen ions. So that's what those brackets mean. So first off, let's give an example of concentration notation. So it means specifically the molarity of. Yep, write this down. So in concentration notation, when you write a formula inside brackets, like this example right here, you see the CO3 -2, that's the carbonate ion, written in brackets. That means the molarity of carbonate. So if we wanted to write the molarity of HCH3COO, if we wanted to abbreviate that, we'd say in brackets HCH3COO. That's how we would do that. And what would this mean right here? Brackets HSO4 minus. What does this mean?
Molarity.
Molarity of.
Molarity of
HSO4 minus. That's all that means. Okay? So that's something we're going to be using for the remainder of the year. Okay? We're going to be using that notation. It's pretty common. Okay? So moving forward, pH. We're going to talk about the pH scale. Okay? First, we're going to copy, I'll copy this down. So a logarithmic scale, it's something referring to the exponent. We are referring to the exponent of 10. So, for instance, it's not a linear scale. So, if I have like a pH of 2 compared to pH of 3, that's my solution. It's not one more in the scale. It's referring to the power of 10. The Richter scale, which measures the intensity of an earthquake. You might hear on the news there was an earthquake of a Richter scale rating of 6. Or a Richter scale of 7. So it's not just one more in intensity. It's referring to the power of 10. So a magnitude 7 earthquake is 10 times more intense than a Richter scale of 6. Because it's one more, it's 1 power of 10 more times that one. Magnitude 8 is 100 times, or 10 to the 2. So the difference in the scale refers to the difference in the power of 10. So it's like 100 times.
Like the whole 10 thing?
The power of 10. So it's like 10 to the 2. So if you're 2 different in a Richter scale, it would be something like 10 to the 2, 100 times that. So say, for instance, if we're comparing class size, let's say a class size is about 20 people. Let's say the school size is 2,000 people. Let's just say easy numbers. So if you're doing a logarithmic scale, a class size would be 1, and the school size would be a 3. So that would be like a logarithmic scale version for our high school. So if we had a class of 20 people, and the school size of 2,000, we'd say that the logarithmic scale of the class would be 1, and the school would be 3. But it's not like there's 3 times as many people in the school as there are per class. There's 10 to the power of 3 times that.
So 30.
No, 10 to the 3 is 1,000. Okay? Referring to the exponent. Okay? So that's okay. We're very simple. We're not getting too complicated with that. Most of it's going to be done on our calculator. So the pH scale is, you don't have to copy down this chart. I'll explain it in just a second. Just make a bullet point, start a new page in your notes here on pH, okay? Write these 2 bullet points down, and then we'll get started. pH is the negative log of the hydrogen ion concentration in the solution. So a pH of 2 means that the hydrogen ion concentration is 1 times 10 to the negative 2, or 0.01. So you guys get to see, like, the concentration of hydrogen ions in pH 5 is 1 times 10 to the negative 5. Now remember, 10 to a negative power just means it's a decimal. Doesn't necessarily mean it's a negative number. The sign of a number has to do with the sign in front of it. The exponent, if it's a positive exponent or a negative exponent, if the number in front of it's positive or positive, it's still positive. Okay? So it doesn't mean sign, it just means it's a small decimal. So 1 times 10 to the negative 2 is 1/100th. It's just like 1 penny is 0.01 of a dollar, or 1 times 10 to the negative 2 of a dollar. Okay, remember we talked about that in scientific notation way back when? Okay, so a pH of 8 means that it's 1/100 billionth of a molarity concentration. So it's a very small concentration here. pH of 14, let's say, a pH of 12 means it's a molar concentration of 1 trillionth. 1 millionth of 1 millionth. So it's a very small concentration.
Wait, 1 trillionth or 1 millionth?
1 trillionth is 1 millionth of 1 millionth. Okay? So it's a, really?
No.
So it's 1 out of if you had 1 out of every million and then you took that from 1 out of every million.
I don't think it's a trillion.
It's just like if you had a million millions, that's a trillion. So if you had $1 trillion, you'd have $1 million a million times. It's a lot of money. Okay? So it's like a billion is 1,000 millions. Right? If I had a million 1,000 times, that's 1 billion. Okay? So moving on. So take out your calculators. Okay? And we're going to do some calculations. All right? So when you guys are calculating these values here, on here, what you guys are going to do, so if you wanted to know the pH, look up here. Yes, but follow along with me. So pH of, if I have a 0.01 molarity hydrochloric acid, my concentration of H plus equals 0.01. If I want to take the pH of that, what I plug into my calculator, pH equals the negative log 0.01. That's how I calculate that value in the calculator. And this number equals 2. So what I want you guys to do right now, everyone I want to do this, I want you guys to take the negative log of 0.001. Okay? So just take the negative log of this number, just like I said this way. Type in negative log, this is an example, negative log of 0.01 is equal to 2. Nope. So hold on. 2, 1. So what we get here is when you type in the log of 0.001, you get, if you get a negative number for that, you want to make sure you put the minus sign in front of the pH. So like the negative log of 0.005 is negative 2.3. Negative of a negative becomes a positive 2.3. Okay? Normally your pH scales are going to be between 0 and 14. Everything in our class will probably be that. So let's figure out this. How many times more acidic is pH 2 compared to pH 6? So we're going to look at this scale. Remember, it's a logarithmic scale. So which one's more acidic, pH 2 or pH 6? 2. pH 2 is more acid. How many times? How many powers of 10 are we different? What's the difference between 2 and 6, or 6 and 2? So I'm 10 to the 4 times more acidic. So that is how many? 10,000 times more acidic. Okay, I know. So let's talk about this. Okay, here, I'll pause it for a second. 3, we're recording now. So pH 4 compared to pH 5 is how many times more acid? What's the difference in number? 1. So it's 10 to the 1 times more acidic. How about this one? 10 to the 3 times more acidic, or 1,000. How about this one right here? 10 to the 10 billion times more acidic. Okay? So remember that this logarithmic scale, we're talking about exponents. Okay? It makes a big difference. Okay? So if like I owe you like 20 and I give you 20 cents, but I really owe you $20, that's a big difference. So the magnitude is very important. The magnitude is the power of 10. That's what I mean by that. Okay? So we're going to pick up with this next class. And we'll talk about the pH square. All right? So, hold on. Let me just stop recording. Okay, good. What's your question?